It feels like every time you learn to do something in math, you then learn to undo it. Okay? So you learn how to add things, and then you learn how to subtract. You learn how to multiply, and then you learn how to divide. Okay? And anytime you're solving an equation, you're essentially undoing a bunch of stuff. If I look at 2x plus 3 equals 5, and I want to get to what x is, I need to say, well, right now I'm adding a 3. Let's undo that. Let's subtract over the 3 to get 2x equals 2. I still want to get x by itself. I'm multiplying by 2. Let's undo that. Let's divide by 2. And so I get x equals 1. So solving equations is all about undoing whatever we've done to x. Well, when we're working with functions, we have some specific notation and vocabulary to talk about undoing things. Okay. So for example, if f of x is x plus 2, I would say that what the function f does is it adds 2 to my input. Now, if I want to undo that, I'm going to undo that with the inverse function. Now, not all functions have an inverse because not everything that I can do can be undone. But adding 2, I can undo that. So I would write that f inverse of x. Okay. Now, this we read as f inverse of x. This -1 is not an exponent. That is what we call an inverse sign. Okay. So f inverse of x is not the same as the reciprocal of f of x. If I mean the reciprocal of f of x, I either write 1 over f of x, or I could write in parentheses f of x raised to the -1. That is now an exponent, but when it comes right after the f sign, that's an inverse sign. That's saying we're talking about the function that's going to undo the thing that f does. Well, how do you undo addition of 2? You would subtract 2. So this would just be x minus 2. In both functions, x is just a placeholder for my input. Okay. If g of x was 3x, g is the function that accomplishes multiplication by 3. So how would I undo that? Well, the inverse function would be x divided by 3. To undo something, I generally do the opposite thing. Okay? So that's one way that we have of thinking about these things called inverse functions. Now, that's not necessarily going to be sufficient because as we get to more complicated examples, it might be a little bit harder to figure out how do I undo this very complicated process. But I think it's important to understand that that really is what inverse functions are doing. And so while we'll develop other ways of looking at inverse functions, I think this is a very important start. So what I'm going to do is I'm going to just put some functions up here on the board. I would like you to pause the video and see if you can write their inverse function, or say no, the inverse doesn't exist. The thing that that function is doing cannot be undone. Okay. And when I say it can be undone, I mean undone uniquely. Okay. So let's just let f of x equal x plus 7. Let's let g of x equal 3x minus 5. Now, notice here, g is actually doing 2 things, okay? So you're going to have to undo the whole thing if that's possible. And let's let h of x equal x squared. Okay, so what I want you to do is pause the video, try to, for each of these, write the function that does the opposite thing, that would undo what this function is doing, if possible. And if not possible, just say so. So f of x is the function that has me adding 7. I can undo that. The opposite of adding 7 would be subtracting 7. So we can say f inverse of x would be the number that subtracts 7 from things. G of x has us doing two things. We multiply by 3, and then we subtract 5. Okay. So I've got two things that I need to undo, and I have to pay attention to the order. Order of operations would tell me that I would multiply by 3 first, and then subtract 5. So when I find the inverse, I'm going to do the opposite things in the opposite order. So I'm going to first add 5, that undoes the subtraction, and then divide by 3. Now, why did I have to reverse the order? Well, usually when I'm lecturing on this, I will point to my feet and say, I'm very proud of myself today because I remembered to put my shoes on after I put my socks on. That's a case where order matters. You generally need to put your socks on before your shoes. You can't see, but I'm barefoot right now because I don't need to be wearing shoes because this whole online thing. So I'm not going to point to my feet, but I will point to that example. When you are getting dressed in the morning, if you are going to wear shoes and socks, you put on the socks first and then you put on the shoes. Now, when you get undressed at night, you don't take the socks off first. You take the shoes off first. You get undressed in the opposite order in which you got dressed. Okay. So it's the same thing here as well. If G does two things, first multiply by 3, then subtract 5, the inverse function is going to undo them in the opposite order. First, undo the subtraction by adding 5, then divide that result by 3. Okay, h of x was x squared. Can I undo that? It's tempting to say, yeah, you can undo squaring by taking the square root. But you can't. Because remember, the square root of x squared is the absolute value of x if we're working in the real numbers here. I probably should have said, we're working in the real numbers here. So absolute value does make sense. Even in the complex numbers, though, there are two numbers that would square to give you the same thing. So even if I were allowing myself to say work with I squared is -1. The opposite of I, quantity squared, is also -1. So if I know what I have here, how do I get back to the number that I started with? There isn't really a unique way. So this function is not invertible. Okay. And as we continue through this section, we'll get a criteria for when functions are and or not invertible. But essentially, if you think about it, if I know I did something, I squared something and I got 4, how do I undo that? How do I get back to what I started with? Well, I don't know whether the number that I squared was 2 or -2, because either one of them would have given me 4. So it's not undoable if I can't look at the result of having done something and say this must be what I started with. With f of x, if that gave me 10, I'd say, oh, if I added 7 and I got 10, I know I started with 3. But with x squared, if you tell me it's 4, I don't know whether I started with 2 or -2. So this one is not invertible.